because we want to avoid the fallacy of committing the consequent, is there another method that we can rely on that will give us confidence in our results? And the answer is falsification. Falsification, and specifically the idea of modus tollens, gives us the proper logic of science that we have been relying on for a long time now. And it was most famously advanced by Karl Popper, who is a scientist, philosopher, and he basically said that the only thing that we can know for sure is what we do not observe. So let's go through these premises and then the conclusion and see why this is the case. So premise 1 is the same, exactly identical to premise 1 in the previous example. So if there is a mediation relationship in the population, I will observe this certain pattern of B weights in my analysis. Premise 2, I did not observe that pattern of B weights that I expected to see. Now, assuming both premises are true, premise 2 may be false due to type 2 error going on, but assuming they're both true, then the conclusion will also be true, and it necessarily follows, that means it's always going to be true, it never can lie. The conclusion is that we can say that there's no mediation relationship in the population. So let's apply modus tollens to the Seattle example that we were working with before. Premise 1, if I'm in Seattle, then I'm in Washington. Premise 2, I'm not in Washington, so the natural conclusion to that is that I'm not in Seattle. And it's always true. Unlike when we affirm the consequent, it can be true some of the time and false a lot of the time. In this case, it is always true. So this is the proper way that we test hypotheses, but the question may be popping up in our minds at this juncture, and that is there any reasonable way to infer a mediation hypothesis or proposal that we have and do it correctly? So is there any way that we can say with confidence that this mediation exists? Well, the answer is that without proper design of our study beforehand, there's no way to infer causation. Without randomization, without control, there's never, ever a way to prove or demonstrate, I should say, that's a better word, to demonstrate causation. Now, that being said, it doesn't make sense that if we cannot manipulate a variable and randomly assign certain people to be exposed to the variable, that trying to demonstrate causation is a waste of time. That's not the case. Sometimes there are variables that we can't randomly assign people to groups, but we should never stop trying to demonstrate some evidence for causation. Doesn't mean we'll ever know it with the certainty that we would if we had the proper design, though. So there are limitations, but it's important to keep thinking through logically why this might be the case. When there were scientists trying to understand the smoking and cancer causal link, I don't know of any randomized trials where some people smoked and others didn't, and they were randomly assigned to those conditions and then they were tracked over time. Maybe those studies existed, but most likely there was just a lot of different pieces of evidence that were coming together to lend and build a case for this causal relationship. So it may be worth our time, depending on the stakes involved, to think through what are the alternative explanations. Let's explore those. A lot of times in our research, when there's non-experimental design, there's just a throwaway line in the discussion section and the limitations kind of saying, we realize that we can't make causal inferences because there was no experimental design involved. And then they move on to other things. And that is true, but in my view, it's incomplete. And it's incomplete because let's talk about alternatives then, and why those alternatives aren't plausible or are plausible. So why not have a discussion about that? And so there are different facets to this, so just keep thinking about the logic of science versus affirming the consequent. Think about what we can versus what we cannot say about the results of our study.